eyes dog or blue eye dog?
Oh, not
That's
like
a
that.
blue eye dog, and that's a common infection with adenovirus 1. Now, can you describe what's going on here in that picture?
Liver looks friable.
Hmm?
The liver looks friable.
The liver.
Looks friable.
Okay. What else? What happening to the liver? I mean, do you see the top? You have a normal liver. There's necrosis. I mean, you see the black spots, and you see the congested liver. Okay. So that tells you two things then here. The liver is affected, and it tells you there is bicorneal opacity. And this is canine adenovirus 1, which is also called infectious canine hepatitis. Now, although the liver is affected severely, also other organs are affected. So this is a systemic disease. It's not only the liver which is affected. DNA virus, again, replication occurs in the nucleus. And because of the damage of the liver, then you expect that the clotting factors are not being produced. So you expect thinner blood. And if you have a thinner blood, what do you expect? You expect hemorrhage. And what else? Edema. Edema and hemorrhages. Okay? And that's what happens with this disease. Now, if we look at the other species, obviously it affects several species. But if we look what happens in larger animals, usually the disease is asymptomatic. It's only in smaller animals, and particularly non-mammals, where the disease can be severe, in addition, obviously, to dogs in mammals. Okay, so what is adenovirus 1 infection? It causes respiratory, ocular, and systemic disease. So when you hear adenovirus, adenoviridae, a family of viruses, think respiratory, think ocular, think systemic disease. It affects the other animals in the Canidae families, foxes, wolves, coyotes, skunks, and bears. Now bears obviously no. It's antigenically related to canine adenovirus 2. And that's important because canine adenovirus 2 does not cause similar symptoms. It causes much milder symptoms, usually respiratory, and it does not cause corneal opacity. Now, the vaccine that you give to the dog has the canine adenovirus 2, not 1. And the reason for this is because the canine adenovirus 2, it can protect against adenovirus 1. It does not cause corneal opacity, and it does not shed the virus for a long time, which is important in transmission. The virus entered the nasopharyngeal route, and obviously conjunctiva, where the lesions occurs. And transmission, because it entered these routes and the presence in nasal cavity as well as in the saliva, so transmission, and because it's secreted in urine and feces and things like that, so transmission in this case is due to contact of dogs with each other. So let's recap a little bit. It enters the nasopharynx, usually mild respiratory diseases. So with adeno 2, with adeno 1, it's a mild respiratory. However, it's severe systemic disease. Causing nasal discharge tonsillitis. The oral route, it causes diarrhea, malabsorption. Into the conjunctiva causes conjunctivitis. The virus then, it can, from those places, whether it's conjunctiva, whether it's oral, whether it's nasopharynx, it can enter the blood, causing viremia, and from there it spread systemically to all organs. Now, particularly the liver is affected, and the gallbladder, which are both characteristics for differential diagnosis. We're going to see how we could differentiate adeno from parvo.
The opacity you see, is that like corneal edema, or is
It's an infection, inflammation.
Okay.
Yeah. Failure of clotting, obviously, causes the edema and the hemorrhages. Now, as I said, when it comes to respiratory symptoms are mild, and obviously they become prominent in the immunocompromised animals, in animals which are unvaccinated and younger dogs. There are several stages of this disease. The peracute one. The peracute one is characterized by sudden death, and believe it or not, within 3 to 4 hours, sudden deaths can occur. So again, it's uncommon in vaccinated animals. It is common in the younger animals and immunocompromised. Now, characteristics. Symptoms is usually the jaundice, the hemorrhages, obviously. The jaundice, why do we get jaundice, or why do animals get jaundice? Breakdown of what? Of red blood cells. Okay, so bilirubin, is usually released from red blood cells, and the liver usually take care of bilirubin, make it more complex, so that it doesn't stay in the blood circulation. But if the liver fails, then it cannot remove bilirubin, and as a result, we get the jaundice. The opacity we talk about, but very important to remember is that the opacity is not a symptom that is presented when the animal is infected recently. This happens after recovery of the animal, rather than during the infection process. So it takes some time for this to happen, in 25% of dogs. Now the lesions, as I said, the characteristic lesion, although other organs are, they are affected, the characteristic lesions, hepatic cell necrosis, thick and edematous gallbladder, as well as the kidney cortex being affected. So the question, how do we, differentiate between adeno 1 and canine parvo 2? And you expect those questions in the exams. With parvo, there is no respiratory disease. And if it happens in adeno, it's a mild. So it can be a little bit tricky. It may not be present, it may be very mild, but there are other symptoms. The jaundice, obviously, does not happen in parvo, it happens in adeno. The ocular disease does not happen in parvo, it happens in adeno. The gallbladder thickening and edema in adeno. The foul, bloody diarrhea, usually it's more severe in parvo compared to adeno. The crits are not affected in the case of adeno. The hemorrhage and the gastric cirrhosis in adeno, and then the abrupt onset of the disease and the bleeding in adeno, which is different from parvo. this case. So differential diagnosis also is important because of the common, diarrhea and systemic disease. Now, the virus is shed, luckily, for months in recovered dogs. So recovered dogs can shed the virus for a very long time. Hence, tests that can pick up, if you want, the virus or viral antigens are important in this case. So you can use, for example, PCR, you can use immunofluorescence, but you can also do serology, like ELISA, hemagglutination inhibition, and virus neutralization test, which we will talk today about all of these. So don't worry about it. The vaccine is, there are inactivated vaccine as well as live modified vaccines. But live modified vaccine containing canine adeno 2 is used, to protect against adeno 1, and usually is given with canine distemper. Okay, so what do we have here? Can you describe the one on the top? What cells we have?
That's a neutrophil.
We have a neutrophil, and what do we have at the bottom?
Barb body.
What's that?
Barb body.
Better than basophil.
Barb body.
Larger nucleus.
Oh, that.
Lymphocytes. Okay, so it's a lymphocyte. Now you see these structures here inside in the cytoplasm, and there, those are inclusion bodies. This is again questioned in the lovely exam. Those inclusion bodies in neutrophil and lymphocytes, characteristic of a virus that can infect those cells and leave these nucleic inclusion bodies. Now this virus also causes crusting on the nose and causing heart path disease. And this is canine distemper virus. Very important. It belongs to the subfamily of Paramyxovirinae, and the genus is morbillivirus. This is an RNA virus. However, strangely, it leaves intranuclear inclusion. So RNA viruses, usually they carry with them RNA polymerase, so that they don't need to go to the nucleus, really, because they don't need DNA polymerase. They have already packaged, if you want, the RNA polymerase. So they replicate usually in the cytoplasm. So, and this virus does actually replicate in the cytoplasm, yet the inclusion bodies are in the nucleus. So what happens? So in this case, what happens is that some of the proteins that are including the capsid, empty capsid, and so on, they transport to the nucleus, but the virus does not actually live in or replicate in the nucleus. So this is why you have the intranuclear, sometimes inclusion bodies. By inclusion bodies also, as we saw earlier, they are present in neutrophils and lymphocytes. So this is where replication occurs in the cytoplasm. Yes?
Can you explain again why they're in the nucleus?
Okay, so some proteins, from in the nucleus, they get transported to the nucleus through a mechanism a little bit complicated, not understood very well. But the presence of those proteins in the nucleus causes the presence of intranuclear inclusion body. Though, as I said, the main replication, the actual replication occurs in the cytoplasm. Okay, now this virus causes syncytium. Do we know what syncytium is? We know.
Remind us.
Right, okay, fusion of several cells into one giant cell. So that's actually very characteristic. If you take a smear you will find that you will find the syncytium in the tissue. Now, the characteristic thing about this virus, it binds to the SLAM receptors. Yes?
Is there, so this syncytium, would you say that
Several cells fusing.
what was that? When there's an accumulation of cells that block off a virus, what's that called?
Giant cell?
Is a giant cell a syncytium?
Is what?
Is a giant cell a syncytium? Would you say that?
Syncytium, yeah.
Okay.
A giant cell which has several nuclei, okay, is a syncytium. We see this in the lab. So it binds to the SLAM receptor. And what is SLAM? It stands for signaling lymphocyte activation molecule. Now, not only lymphocytes are affected, but also macrophages and dendritic cells. So you expect, when you hear Paramyxoviridae, virus belonging to the Paramyxoviridae family, you expect, first of all, respiratory disease or respiratory symptoms. Secondly, you expect immunosuppression due to, obviously, the multiplication and killing of lymphocyte and other cells. And thirdly, neurological symptoms. So three things: respiratory, immunosuppression, and neurological symptoms. This family is huge. It has many important viruses. For example, in Newcastle, the peste de Tiremont. It has the Hendra virus, the Nipah virus, bovine respiratory syncytia, and Turkey rhinotracheitis virus. All of these we're going to study, later on. So it's an important family of viruses. Now, what is it? It's highly contagious in dogs. It's well controlled by vaccination again, but again, the problem, younger animals, immunocompromised, and so on, can be affected. Not only it affects the Canidae family, it affects the Felidae family and the Mustelidae family. So all of these are affected, hence contact with wild animals is important in this case. So has to be put into consideration. Most of the symptoms are subclinical. So most of all the disease, not the symptom, the disease is subclinical. So exhibiting really very, very, very little symptoms in 50% of cases. However, in the mild disease now, you will see, the build-up of, first of all, respiratory symptoms, and respiratory symptoms that include the usual thing, coughing, difficulty in breathing, nasal discharge, etc. Now, when it becomes severe disease, now you have the virus, causing viremia. Usually the viremia as a result of increased replication of virus in certain location. Once the number of the particles, is high, then it can enter the blood circulation and causes viremia. As a result of the presence of the virus in blood, it infects the leukocytes, causing the leukopenia. It infects neutrophils, and it does not affect macrophages in the blood. Yeah? Where do macrophages exist? In the tissue. Okay, they are monocytes before becoming macrophages. Okay, in the tissue. And now the other stage, you have what's called the progressive profound disease. This is when the CNS or neurological symptoms occurs. And the neurological symptoms, also there is a debate here, but the debate is not whether they occur or not, it's about timing, when they occur. There are reports that it can occur in dogs less than 6 months old, but if you want, the consensus is that this is a later stage. So you may not see the CNS signs at all. And if you see them at later stages. And what is this associated with? With paralysis. The paralysis can occur in all the 4 limbs, and this is what's called tetraparesis. Now I show you the picture of that dog having crust, on the nose, and that's because of the infection of epithelial cells present in those locations, the epidermis, as a result of the infection, you have secretion of keratin, and that the secretion of keratin which causes the crusting, around the nose. The other things we saw is the heart path disease. Again, the virus infects the heart, infects the pads, and as a result of this, because thickening of the pads and making it, difficult for the dog to walk. Now, in terms of transmission, the transmission is mainly respiratory, aerosols. The virus is present in secretions and excretions, and as I said, it infects not only lymphocytes but also macrophages and dendritic cells. So let's recap. It entered the respiratory tract, causing nasal discharge, respiratory difficulty in breathing, and if complicated with bacterial infection, mucopurulent discharge. It binds to SLAM receptors and lymphocytes. When it's present in the blood,